main highlight of our design is our wind turbines are operating while sailing, because nowadays the conventional wind turbines are towed at the lower sailing speed. But why don't we operating our wind turbine at the higher sailing speed? Because when we sail at a high speed, the relative wind speed may even higher, so we can generate more power. And also, the power we generated can be stored in our battery, which provide the power we need to sailing back. And so in this part, I would analyze every routes for the wind condition and the power generation. Okay, let's move on to our today's topic, the power generations by wind turbine. So just like I said before, the wind turbines on board of our vessel are generating power while sailing. So here's the profile of the wind turbine. The rated power is 20 megawatts, and the important part is the rated wind speed is about 13.5 meters per second, and this means if the wind speed can reach above 13.5 meters per second, then we can have the rated power. And the average potential wind speed in North Sea is about 8.98 meters per second. So we can change this value by power load to calculate the wind speed at our hub height, which is 11.52 meters per second. And this is the relative wind speed concept, because if you see the right-hand figure, when our vessel is sailing at the 15 knots, which means we have the relative wind speed, like the red arrow here, have a 15 knots. And if we have a specific route, so we have the relative wind speed with our encounter by our vessel. And here is the formula of the relative wind speed. And the wind speed of the North Sea is referred from the left-hand side figure, this rose diagram showing the direction from the North Sea. So we can know the relative wind speed that the wind turbine has encountered. And in case of some bad scenario, our wind turbine has a yaw system, which means we can change the direction of our wind turbine direction to align with the wind speed to have a higher rated generated power. And also, another highlight of our wind turbine is the resistance changes, because as you know, there are two effects that will generate force on wind turbine. One is the tower resistance, and this is always increase the resistance. While another one is when operating, the blade also generates thrust, and this thrust in some direction may increase or lower our resistance. So by using the generating power and the resistance changes in our wind turbine, also compare with the routes from 1 to 6, we can calculate the table for each track. And for most of the track, the power we generated, which is the above figure, is higher than the power required for our brake power. But only in track 3 and track 4, you can see the required power is larger than the power that we can generate. So in this range, we'll shut down the turbines. And how about the remaining power we generated? Well, the remaining generated power would store in the lithium-air batteries that provide the power for sailing back. And this is our presentation. Thanks for listening.